if you don't want your product to reach production from the beginning, it's never going to reach production. 500 kilos, you can manage to be safe, right? But when you come to 1 ton, you can kill someone. In terms of engineering behind, you need to have everything 100% perfect. If you do a project for research, it's extremely hard to turn it into production because when you do it for research, you are more focused on solving the problem and you don't really care about the user.
Welcome to the InnoHyve Podcast. In today's episode, we sit down with Wilson Colin, lead mechanical engineer of Lexxpluss. Lexxpluss revolutionized robotics by creating cutting-edge autonomous mobile robots that supercharge logistics and manufacturing. As always, you can find out more about our guests in the description below. We feel incredibly fortunate to interact with such inspiring people, and we're on a mission to share that inspiration with you. If you want to help us, like, subscribe, and share this episode. Enjoy, and don't forget to stay curious. Let's do it. Wilson, thank you very much for being on the InnoHyve podcast today. Really appreciate it. We had the chance to have you on the Inno Talks a few weeks ago, so followed up to you and say, hey, why not record a podcast and I guess learn more about what's a mechanical engineer, what's a mechatronics engineer, what do you work on. So let's dive into it right away. Tell us maybe a little bit more, Wilson, briefly about yourself and then also what you do currently.
Yeah, so I'm a robotics mechanical engineer, and I like to make the distinction of robotics mechanical engineer because I cannot build a car.
Mm-hmm.
If you ask me to do it, it's quite a complicated task. But if you ask me to build a robot, I can do it. And I think it's same as software engineers. You have specialties, right? And it's not because you're a software engineer that you can do everything in software. So my specialty is toward robotics, and it's mostly playing with motors, with sensors, and kind of making hardware around that. So so I'm a robotics mechanical engineer, and I think I could also be under the umbrella of mechatronics, in the sense that I don't only do the mechanical, I also do some electronics and some software. But it's a very prototype level. So, I cannot be specialized in everything.
Of course.
And that's why my specialty is mechanical side. So, about me, I come from France, and I study robotics at university. And then I got the chance to do an internship in Japan. Love the country. And I think that's how I ended up here working.
Right, you were supposed to come just for an internship, never came back home.
Exactly.
Classic.
I came back home, and then I realized I was missing Japan. And I came back to Japan, and then after the second internship, I got the job, and I was like, okay, I'm good here.
Interesting. Why robotics? Like, what led you to study robotics?
It's a good question in the sense that at first I was not interested in robotics. I wanted to be a fighter pilot.
Okay.
And I applied for the school 2 times, which was the military school in France. But I didn't get into the school. So I had to figure out what do I do if...
How come you didn't get into the school? Like, how hard is it?
It was a complicated system because basically there is a ranking, which is based on your grades, but also based on the status of your parents. So if your parents were in the military and they died, then you get points, which makes you like a preferential to join the school. Then if your parents are still in the military, you're on the second base. And then if your parents are in the, I think it was, I forgot the name. But there was some ranking like that. And so regardless of how good were your grades, if you are not if you don't get those points of having your parents in the military or things like that, then you don't get to go to the school. So in the end, it didn't work out. And I kind of always like physics, and I like playing with stuff, building, mostly reverse engineering things, kind of disassembling my toys and just leaving them like that. So kind of breaking my toys when I was young. And there was an engineering school in Paris that was doing robotics, that had a robotics program, and I thought, yeah, it looks fun, I'll give it a try. And I got I passed the exam, and then I ended up in the school, and that's how I went.
Then basically you graduate, you come to Japan for an internship.
Yes.
Which company did you get an internship?
So in the engineering school in France, you have to do an internship abroad.
Mm-hmm.
And I thought if I have to go abroad, I'll go as far as I can. And Japan is kind of pretty far from France.
Yeah.
So there was a partnership between my university and Tokyo Institute of Technology in Okayama Station in Tokyo. And then I did a 2-month internship in a space laboratory there, which was really cool. I really liked the work there. We were working on a, how do you call it? Infinite degrees of freedom. So basically, there is, it's a hyper-redundant robot, which means, there is many joints you can move to reach one position.
Mm-hmm.
So, for example, if my elbow was not in the way, I could maybe reach this place from like bending my elbow like this, but also bending it the other way. You see what I mean? So you have 2 configurations. And then if you put many links like that, then you have an infinite number of configuration that you can reach this point. So they were working on that for satellite servicing.
Okay.
Which was basically it was kind of a cable that they could extend, and then by pulling some string, they will bend it in very complex shapes to reach a very specific position. So it was a very cool topic.
What will be the use case for a kind of satellite?
The use case will be that, if you have a normal robotic arm, you are very limited in terms of your workspace.
Right.
But if you have a cable that you can extend for a very long distance, and then you can articulate many joints, then you can go around obstacles, you can reach some very complicated areas that you wouldn't be able to do with a regular
kind of a
robotic
snake
arm.
robot.
Exactly, kind of a snake robot. And it was essentially to perform some tasks on satellites.
Like
to
maintenance.
Yeah, maintenance and servicing. So it was mostly a research project. But it was only a 3-month internship, so there's so much you can do as a student on 3 months. But it was a very interesting project. And then after that, I got to travel for 1 month in Japan, from Tokyo to Fukushima with local trains.
Okay.
So it was so.
Fell in
nice.
love with the country at
Yeah,
that moment.
fell in love with the countryside, and
then went back to France.
then I went back to France. Actually, I went back to Switzerland.
Okay.
I went to Switzerland, and I studied in EPFL, which is, I forgot the name. École Polytechnique Fédérale of Lausanne.
Okay.
It's a school in Lausanne, so the French part. I did 6 months there. Really cool people, really cool project. I love the school. It was amazing. But I had to do another internship, because in the engineering program you need to do a 6 months internship at the end of your to get your diploma. And I got the chance to go back to Japan with Rakuten.
Oh, nice.
Because they had a robotics. They wanted to open a robotics team, so I was the first intern.
Did you apply by yourself or like?
Yeah, I just applied to a bunch of companies, and I wasn't really interested by the company. I just wanted to come back to Japan with robotics, and that was the only goal. And Rakuten gave me an offer, and so.
So that was a paid internship.
Yes, that was a paid internship, which when you're a student, it was quite a good pay, to enjoy Japan. So. That's how I ended up in Japan. And then after the internship, I said, I want to stay. Can I apply for a full-time position? I applied, I got the job, and I stayed.
Nice. What did you work on at Rakuten?
During the internship, I worked on drones. So the project I was working on was autonomous drone to plant the seeds for the farmers. I think nowadays it's very... You have a lot of drones that can do that.
It's common,
So that was the project I was working on at that time for the 6 months. And I was working on the mechanical side, so building the drone, which was around kind of a seeding bag that will spread the seeds the way we wanted. So the whole drone was built around that.
Did that project ever gone into market? No. Just
No,
internal.
it was just like I was the only intern doing mechanics, and when you just get out of school, the quality is not as good as I will do now. So I don't think it ever came to anything.
I mean, but it's insane. Like, so Rakuten asks you, like, hey, can you work on this drone project? And you're the only intern. And how many people with you in that team? Or
so the team I was in was maybe 10 to 12 people.
okay,
But there was various topic investigated, and I was the only one working on the drone. So I did a bit of the control to stabilize the drone when flying. I built the drone, and then I did some test flight, and that's as far as I went on in 6 months. I got the chance to work a little bit on people detection from the drone. So we were using the Jetson TX2, which has NVIDIA was providing a neural network to detect people, and so I just essentially deployed that and tried to see if we could detect people around, because in Japan, safety is a big concern, and so we wanted to check that we can detect people around and just kind of use this data to avoid crashing into them.
Makes sense.
Yeah.
What happened after Rakuten, or which other project did you work at Rakuten?
So after my internship, I joined as a full-time employee. And then at that time, they wanted to do the last mile delivery, which is basically when the package needs to be delivered to the customer, right? There is this step between the post office to the customer, which is usually like a few kilometers. And this is a very big bottleneck in e-commerce, because you need to rely on the postman, and then it takes usually a lot of resources to get there. But what they wanted to do is use autonomous ground vehicle to bring the package to the customer, which is what's the name of this company? Starship? No, forgot the name. It was one of the first one to do something
in the US, or
I think it was in Estonia.
Okay.
I forgot the name. Sorry.
No worries. I'll search it up.
Yeah, and so this company, I cannot remember the name.
You will not remember it until the end. Don't worry.
So we wanted to work on doing this last mile delivery. So we started to have more people joining the team, and the robotics team grew up to 6 people. I think 6 or 7 people.
Okay.
And we had some software people working on the SLAM, which is the localization and mapping. I was working on the mechanical side, and what Rakuten wanted to do is that they wanted to make this autonomous ground vehicle being able to climb stairs, because unlike the US, Japan is a lot of staircase, like a lot of them, right? It's always up and down, and so they wanted to be able to have the AGV, like be able to climb stairs, so that we could reach different customers. It was interesting for me, but in Japan we have earthquake, and when you have a 30 or 40 kilogram robot on the stairs, if there is an earthquake at this time, you don't want it to fall down and maybe potentially injure some people. Like,
how heavy are those robots?
So the one we were building was around 40 kilos with
40,
the batteries
40.
And everything.
You don't want to receive that.
Yeah, right. So the project was interesting for me because it was my first project. But I think it was really oriented toward research and development, more research and development. So we made one robot only. Actually, we made a second one after, but it was kind of a different configuration, which was mostly for the software team to work on the SLAM. And we were doing that in collaboration with Tsukuba University.
Okay.
So we were working on their campus to autonomously navigate from a point A to a point B, taking the elevator. So we had a small robotic arm to push the buttons of the elevator. It was a good time. I really loved the time in Rakuten. Cool project, and yeah.
Nice. Did that project ever?
No.
This is pure R&D, basically, department R&D.
Yes, it's pure research. There was very little development toward production or.
What makes at some point one of those projects like viable for production? Like what's the gap? Because I'm sure eventually they hope for some project that okay, this is for the public or for production. Like
I personally feel like if you don't want your product to reach production from the beginning, it's never going to reach production. If you do a project for research, it's extremely hard to turn it into production because when you do it for research, you're more focused on solving the problem and you don't really care about the user, the end user. But if you keep in mind that you want to make a product out of it, then you include, okay, how my user is going to use my robot, right? And that's going to change the architecture of your robot like 100%. Because for the research, you will be trying to just solve the problem as best as you can. While if you want to make a product out of it, you will be less focused on making the best robot you can, but more focused on making it such as it's user-friendly, such as it's targeted toward one customer or toward like, how to say, like one problem that you want to solve, but yeah, keeping in mind how you will sell this solution actually.
Yeah, making it accessible. The
Yeah,
cost is also
exactly.
important. Why would a company purely go like then on the research with this research mindset? Is it like to discover some technology? Like what's behind the thought process?
I think, like big companies, they do some research to potentially find some new product they could make, right? But to be honest, I think most of the things I worked on at Rakuten in this research department was never meant to go in a product. It was more like investigating some areas and see if something could turn out of it. So I think something that could have worked for this company would have been like, oh, okay, we have this technology that works more or less, right? And we see a future for this technology. Let's create a department and just focus on that and probably restart everything from scratch. Like the first one was more like a proof of concept where you show that you can achieve the goal. And then once you show that, the executive are happy. They're like, oh, I think there is something there. Then they will be like, okay, we start everything from scratch again and we make a department and now we try to get this.
Makes sense. Was that the last project you worked on for Rakuten?
Yes, that was the last project. I think I worked 2.5 years on this project.
And
so
learned a lot of things.
And then after that, the robotics team got dissolved.
Okay.
And we got transferred to Rakuten Mobile. And then there, I had to work on IoT products. So for a year, I found it very interesting. But after a year, I was like, I want to go back to robotics. That's my job. And IoT is fun, but there is no motors. Nothing is moving. And it's a bit frustrating.
So from Rakuten to Telexistence?
Yes, right? Exactly. Rakuten to Telexistence.
Tell us more about your journey in Telexistence.
Telexistence was really great in the sense that I loved the project that we were working on there. It was, I will say that's where my robotics career really started because that's the first product that was meant to be a product that we mass produce. And yeah, I really loved it.
So from the beginning, Telexistence said we're building this for mass production.
Yes, their goal at Telexistence was to make a product that they can mass produce to make money. So there was, I don't think it was ever about research or making state of the art, publishing papers. No, it was let's make something that works, that solves a problem, and let's mass produce it. So when I joined, before I joined, they wanted to send this humanoid in space and do some teleoperation from there. But when I joined, they already started to think, okay, maybe space is a bit complicated, right? So they're like, maybe we can use the teleoperated robot in the convenience store to refill the shelf.
Yeah, and convenience.
Yeah, convenience. It's a huge market in Japan, right? So you can see the potential. And actually, I think a few months after I joined, they started thinking, let's make an industrial robot that just refill the backyard of the convenience store. So, it's where you have all the drinks.
Yeah.
And it just basically taking one drinks from the restocking shelf to the
Keep
display shelf.
filling it up and
Yeah, exactly. Because until their existence, the staff will just go in the backyard, look at all the missing drink, and just do that. Which is, it's 5 degrees in there,
Yeah.
and they have to do that for maybe 2 or 3 hours a day. So,
Not a fun job.
right, it's and plus, like from the convenience store perspective, it's time that they cannot spend with the customer, right? And you would rather automate that with a robot and get the staff with the customer rather than them wasting time in the backyard. So the new project was like, okay, let's build a robot, industrial robot, that can move drinks from one side of the shelf to the other. And what I really loved about it is I joined from the conceptual design. So, we didn't know what it would look like. At first, we had a humanoid.
They didn't really use the humanoid robot for the space? They didn't reuse the same...
No, because, the humanoid robot is so many actuators, so many motors. You have the wrist, you have the elbow, you have the shoulder, and then all the way until... There was no legs, so all the way until like the
whole torso,
yeah,
basically.
the torso. And that's too expensive. You don't need that much degrees of freedom. You don't need that much motors to just move a bottle from one side to the other, right? So in the end, the idea was to put an arm on a column that could move up and down, and then put that on rails that could move from one side to the other of the convenience store. And because I joined from the conceptual design, which is like, okay, this is what we want to do, how we do it, then I was in charge of the design of basically the whole rail at first. And, I had to think about what would be the best way of doing it. Should we use some wheels and then just move from one side to the other with wheels? Because the advantage is you don't need to deploy any platform, right? You don't need to screw things on the floor. You just need to put the robot there. But in the end, I consider that wasn't the best option. So
why?
Because the thing is, software, they want the robot to be extremely precise. Like it's sub-millimeters precision, because if they know exactly where the robot is, it's easier for them to be able to reach the target they want. And they want this to be repeatable, which means that if you do it 100 times, you always end up at the same position. And if you use wheels, essentially, the way wheels work for cars, for anything, is that you rely on the friction between the wheels and the floor. Such as you will be able to move to your destination. But if you have some slip, then your encoders, they give you like they tell you that you moved, but you didn't move. And so the repeatability on that is hard to achieve.
Yeah, the math is more and more inaccurate.
Exactly. And plus, it's, so the slip creates some errors, but also there is so much precision you can do with wheels. If you want to tell the robot, please move 0.5 millimeter, and do that with wheels, it's actually very complex. So I decided that maybe it will be better for us to rely on rails and use some rack and pinion, which is essentially a long stick with teeth, and then a gear. And so we could move along this rail and be relatively precise with not that much backlash, which is like how much the actuator moves without the robot moving. And, the thing is, when I designed it, just the rail was, I think, 500,000 yen. And I had to sell it to the company and say, we should go with that because it's expensive now, but we can make it cheaper for mass production. But it was my first real project leading to mass production, so I was kind of going, it was very risky for me. Because
is that considered expensive, 500,000 for this kind of like...
Yes, it is expensive in the sense that, you try to bring your cost as low as possible, and the rail it was only one part of the robot, right? So if you consider the whole architecture, and
how much will be the whole architecture for that kind of robot?
I don't think I can share those kind of numbers because I don't think they will be happy if I.
Of course.
It's just what I can share is that the price that you have as a prototype and the price that you have as a mass production, there's a huge difference. It's
Right.
like you can cut down the price by 70, 80, 90%. So when I designed the rail, it was extremely expensive, and I had to like convince everyone around me that it will pay off in the end. And so what I did is I contacted some manufacturers in Japan for extruded aluminum. So basically you push some molten aluminum into a die, and then, kind of like the the toys that you have when you're kids, where you push like some dough, and then it makes
it comes out, yeah.
well, it's exactly the same thing. And I thought, this rail, we could use this technology. And so I contacted a lot of manufacturers. I told them, okay, how much will it cost if we want to make this shape, and what will be the challenges? And then we found a few manufacturers that told us, well, here's how much it will cost. And in the end, I think we went from like 500,000 to, I think it was something like 5,000 or
Wow.
10,000 yen. And that's where I realized that, if when you design your robot first, you need to keep in mind what's going to be the mass production. Because, if I had considered that 500,000 was too expensive for the rail, I would have maybe discarded this technology, go for something else that in the end will have been more expensive at the mass production level than it was by using extruded aluminum. So if you don't see the whole project, all the way to the mass production, you will miss some very good technologies that are very expensive at first, but that can drastically reduce the cost down the line.
Yeah, like I often hire mechanical engineers for clients in Japan here, but like one of the biggest struggles to find is people with mass production experience. Like, but by the time you're in Telexistence, you don't have that experience yet yourself.
No.
So how do you get to those answers? How do you find out about those things while you never really been there in the first place?
Yeah, so I don't know. It's like I just thought, I think I can make it with this process, and I think it will be cheaper, and that's all that got me started. And then the only thing you can do is just contact manufacturer and be like, here's what it looks like.
Yeah.
Can you tell me how we can make it happen? As a mechanical engineer, you don't have to know exactly how every mass production method works.
Yeah.
You just need to know that they exist, and then you realize on I lost my word.
At scale, like.
No, you rely. Sorry.
Oh.
So you rely on the manufacturer to tell you how to make it happen, because they have dozens of years of experience, and they know all the constraint and all the tweak they can do to the machinery to make it perfect. And that's not something that I want to be good at. I just want to know that it exists. I want to know roughly what I can do with it, and then I just rely on the manufacturer to
Makes sense.
make it happen.
Yeah, you don't try to know everything. You're basically figuring out, okay, this is possible.
Yeah,
this is a viable
exactly.
option. Contact. Interesting.
And,
And so that basically you're taking over at Telexistence right away the whole design basically of.
Not the whole design. So at that time we were 3 mechanical engineers, and the robot was kind of separated in 3.
Yeah.
I was in charge of the whole base, which is 1 degree of freedom, because you want just the robot to move along the rail. And you want to do it with a certain speed, a certain acceleration, and with a certain accuracy and repeatability. Like you want to be very precise when you arrive there, and you want to do it always the same way. So that was my main goal, and the 2 other, one of them was in charge of the torso, and not the torso, but kind of like, the body and the pillar, which is to make it move up and down and to rotate. So that was 2 degrees of freedom. And then another one was in charge of the robotic arm, which is to go pick the drinks.
Makes sense. And so obviously Telexistence right now seems pretty successful. Like they're deploying a lot of robots.
Yeah.
And I guess right now you're working for Lexxpluss.
Yes,
right?
exactly.
What are you working at Lexxpluss?
So at Lexxpluss right now, I'm back on the autonomous ground vehicle, which is what I was doing in Rakuten in the first place. And it's fun to get back to this project with the knowledge that I have now.
Right.
Because when I first joined Rakuten, I had very few knowledge in like how to get a product there. And now I'm really just essentially redoing what I've done in Rakuten, but with more knowledge, and I know how mass production works and really how to get there. And it's a lot more fun now that I know how to make it happen.
Makes sense.
So basically I joined Lexxpluss. So my interview was, they gave me the CAD files, the 3 models of their product, and they told me, what would you improve? And so I spent, I don't know, 2 days, I think, looking at the whole CAD models, and then I found what I would improve.
Yeah.
And that basically became my job when I joined, which was how to make the robot more reliable, easier to produce, to mass produce. And
Is that a typical way of interviewing people? Because I haven't heard that often. Like they just show you the CAD models. And
yeah, that's the first time I had to do it that way, and I really liked it because I start like for me it was interesting to know how far they went. What kind of technology they were using. What kind of skills did they have? So that was interesting, and also finding problems. I knew what I will be working on when I joined.
Yeah, it's such a smart way of interviewing.
Yeah.
And like the model, everything that they showed you is as it is in the company.
Yes.
It's not like they kind of made a case just for you or.
It was an old product,
Right.
So it was not the last one they had.
Yeah.
It was maybe one version before.
Okay. Yeah.
But you don't drastically change everything. So
No.
I had kind of an idea of what they were working on right now.
Yeah.
And I mean, for the company it's good because they can figure out problems they didn't see maybe.
Yeah.
For me, it was interesting to get to know their product and to see what I could be working on. So it kind of felt like a win-win situation.
Yeah, like I will recommend that to some of my clients out there. I think it's a really smart way of interviewing.
Yeah.
Like you say, you know what you're getting into as well. They see how you think, how you work on it.
Yeah.
Like you briefly mentioned like what you're working on right now. Like, are you a team leader in Lexxpluss right now? Like.
Yeah. So right now I'm the. So I joined as the senior mechanical engineer.
Okay.
And I think 3 months later they put me as the lead of the team, which I think was their whole goal from the beginning.
Yeah.
I didn't expect it, but I was open to the challenge. And so now I'm the team lead, and basically I have a bit more management to do.
Okay.
Than expected at first.
So new challenge for you. Like, how many people are you managing right now?
So I'm not the manager of the team, so I'm not managing people. There's 2 people in my team, and the way the dynamics works is that so we have basically 2 products, and each member of the team is fully working on one product, and I'm kind of putting my resources wherever it's needed, and kind of bringing some of my knowledge of what I gain in Telexistence into how we could steer the project toward a better design that is easier to mass produce, or bringing a little bit more. I don't know. I think I'm mostly bringing a bit more knowledge on how to do things.
Yeah.
And that's why I went to this leading position.
Nice. And the product for Lexxpluss, can you briefly explain it to me?
Yeah. So the product of Lexxpluss, as I mentioned, is a AMR, AGV. So it's an autonomous mobile robot. AGV is autonomous ground vehicle. Basically, AGV, the route that they will take to reach from a point A to a point B is already known. They always take the same route. While AMR, from my understanding of the semantic, is that they will figure out the best route to go from point A to point B. So they will usually use A star, which is an algorithm to find the shortest path to your destination, and then they will throw in there some collision avoidance, with other robots or with humans, or so that's the whole point of the MR. And so Lexxpluss is essentially doing this mobile robot that can pick a payload in warehouses or anywhere where you need to move some loads from a point A to a point B. And in big factories or in big warehouses, point A to point B can be 100 meters, right? And if you have people going way in, way back, those 100 meters, it's just such a waste of time.
Yep.
You could just bring the load somewhere and the robot does just this part and have someone else on the other side, and then you are saving a lot of time. So Lexxpluss is trying to tackle this problem in Japan.
Interesting. And like, what's the biggest challenge for that kind of product in general?
I think so. This technology is not very new in the sense that there is already many companies doing it, right? I think where the innovation is coming is more on how to navigate from point A to point B. That's where I think there is a lot of things done and a lot of value added to the product. And I think. Yeah, what was the question again? Sorry.
Like, what's the main challenge? Because I mean, just like a lot of computer vision probably involved, like SLAM, all this stuff. Like,
So, the main challenge that I see in the current company is first the safety. Like the customer, they want the robot to be able to operate in their existing warehouse. They don't want to make the warehouse like only robots. They want the robot to they put it there and the robot figure out how to avoid people, how to navigate from point A to point B. They don't want to modify the whole infrastructure for the robot, which is what Amazon was doing at first. They were separating humans and robots so that there will be no risk. But that's heavy in terms of how to update your infrastructure as a warehouse. So to have the robot cohabitate with people, you need to comply with a lot of safety, because that's the main concern for those companies, for those warehouses, is to protect their employees so that they don't get too many issues with that.
What's the weight those robots can carry around, like?
So at the moment, our robot can carry up to 500 kilos.
Wow.
But we have some customers that could be interested in 1 tons, 2 tons. And it's a big jump, because 500 kilos, you can manage to be safe, right? But when you come to 1 tons, you can kill someone if you mess up. 500 kilos, you will injure someone, but you can make it safe. 1 ton is started to be really like a big deal. Like in terms of engineering behind, you need to have everything 100% perfect. You cannot afford your robot to break, because if it breaks, then the load could fall, and that's a no-go.
Yeah.
So, going from 500 kilos to 1 tons or 2 tons is going to be a big challenge.
Do you guys have to go through any type of third party to approve your product as well at some point? How does it work actually before you can say, yeah, our product is safe? Like, what's the process behind it?
Usually it's with the customer. So the customer is going to come and be like, we want your robot to comply with those standards, which is usually ISO standards. And then what we will do is we're going to read the ISO standard and try to figure out what we need to implement in our robot to comply with it. And once we comply with it, we can tell the customer, here are the features we implemented that comply with your standard, and our robot is matching the standards that you want. So you don't need to be too concerned about those.
Makes sense. Yeah, I mean that's probably the scariest part for designers, and like if something happens, like, damn, what do we do? Yeah.
So like one big thing that we started to do in my team when I joined is doing FEA, which is finite element analysis, which basically we use our software to simulate how does the robot deform when we put the payload on it.
Right.
And by doing those deformation, we can tell what parts we need to make stronger so that it does not start to bend or it does not start to break. And since we started doing that, we figure out that there is some places that we never expected that will bend, or there's many things we didn't expect it, and now that we know them, it's just easier for us to make it such as we can ensure that we will not have issues with the robot bending or breaking itself.
Yeah, I guess a lot of simulation as well, and
So we do a lot of simulations. So FEA simulation, which is mostly in static, which means that we consider that the robot is not moving. We're just putting weight on it and see how it deforms. Because dynamic analysis is a lot more complicated, and it's heavier on your computer also to generate the report. So we are mostly working in statics at the moment. And so we do the simulation. We figure out where are the weak places in our robot. We just adjust the design and then rerun the simulation. If we solve the problem, then we are good to go. And what we do is usually we consider a safety factor, which is, we don't design the robot to handle 500 kilo. We design it to handle 750 kilos or 800 kilos. But what we sell to our customers is 500 kilo because that's what we consider safe. And that's what we can ensure the customer that if they remain within those limits, then there will be no problem.
Yeah, it makes sense. I mean, like mechanical engineering, mechatronics engineering, like I guess, like you explained, like in mechatronics, it's probably a bit of software and like electronic work as well in there. But like overall, like for you, Wilson, like what are the biggest challenges so far that you had to solve in your career? Like specific problems that you're like, man, that was like, I really thought I will never solve that specific problem. Like what kind of problems are we talking about?
I think the mass production in Telexistence was a big problem that I was happy to, design these things so expensive and manage to make it very cheap.
Yeah.
That was a big achievement for me. And another problem that I still haven't solved, and I think it's a very interesting topic, but it's kind of pushing my limits, is to dimension the actuators and the motors. Because, ideally we would like to put the biggest actuator we can so that
What's
we have
an actuator?
An actuator is, so essentially a motor is an actuator, but motor is mostly something that is rotating. But in the category of actuators, you have also like piezoelectric actuator, which is like it relies on electricity to kind of move.
Okay.
I'm not very very knowledgeable on this topic, but it's basically some properties of the material that if you put a very high voltage, then you will get it to move.
Okay.
You find it a lot in the ultrasonic sonars because they can. We might cut on this one because I'm not super knowledgeable in it.
Don't worry.
But in actuators, you also have like linear actuators, which is basically you have a rotary motor that will extend the shaft.
Okay.
And so there is a motor, but the motor it doesn't represent very well the whole product because what you are doing with it is essentially moving a shaft. So this one, we call it an actuator and not really a motor. The motor is really the spinning things that we have, and actuator is more like the global category of things that are moving.
Got it.
You will get like hydraulic actuators, which relies on fluids to get it to move. We're gonna inject some high pressure fluids to push it. You have pneumatic actuators, which will rely on air. And then you have linear actuators that will rely on the motor turning and pushing a shaft. So actuator is really the broad category of
Got it.
And
Yeah, I think most of the companies that I know of use motors usually. It seems like the most common.
So in Telexistence, we were mostly using motors, right? We didn't have any linear actuators. We were using some ball screws, which are essentially a shaft with a kind of a bearing. And then when you rotate the shaft, the bearing is going to move up and down.
Okay.
So we had a motor essentially, and then it was more of a custom made. Well, if you buy a linear actuator, you usually buy a package, and it comes as it is, and it might not be exactly what you want. For us, it was custom made. We made it in Telexistence.
Right.
So
Yeah, big challenge. I mean, like, it seems such a hard thing because I think software it's kind of easier to try things and go back on your code, and but for you, like, I mean, you make a design, you're probably very stressed before going to mass production. Like, it's not the same quality assurance kind of process, I'm sure.
So
right?
we don't reach mass production right. There is
Of course.
so many steps before to get there. Usually we make one prototype, and then our goal is just to make it work.
Yeah.
It will be disgusting, it will be out of specs, which means we will not be going to be able to carry the payloads that we want.
Yeah.
So before to reach production, there is so many steps that you're not so stressed about the production. There is so many iterations to get there. But yeah, so as I was mentioning, usually you want the biggest actuator that you want, the biggest motor, so that you have a lot of power. And then the software team is super happy because, they will have a lot of control over the motor, because essentially the motor, the main things you want to achieve is acceleration, which is how fast you can move to your desired speed, right? If you take 15 seconds to move to like the speed that you want, it takes too long, right? You want to move extremely fast to your desired speed so that you can move at your desired speed for the range of motion that you want.
Makes sense.
Right? And so ideally you want strong actuators for that. But you cannot always put strong actuators, right? On a robotic arm, if the robotic arm is like 500 kilos because you put only strong actuators, then you will need a lot of battery, and then it's a chain. And so you need to find an actuator that is light and doesn't consume too much power, but that gives a lot of performances for the software team so that they can have like control loops that are very sharp. They can reach the position fast and very precisely. And so getting there, finding the proper actuator is still to me very challenging because you need to understand how the software is going to work, what kind of constraint they will want so that they can have the best control loop. And on the other side, you need to care about what has the power consumption, because if you're on a battery, you don't want to drain the battery in 10 minutes. If you are plugged to the main line, you don't want to have huge AC-DC converter, which convert like the alternative current to the DC current. The flat one. And so you need to care about the electronics, you need to care about the software, you need to care about the mechanics because you don't want something heavy. And so you will also care about the gearbox because motors, they spin extremely fast. And the gearbox is essentially reducing your speed so that you will be in the range of the speed that you're aiming. And so when you put all that together, that's really a skill that I'd like to have, is finding the perfect actuator that software team is happy with and that satisfy electronics and mechanics.
Yeah, it's the first time that I have such like, I guess, deep conversation with a mechanical engineer, and it just finally hit me like you have to take care of so many elements basically. I didn't realize before. Like, I mean, software is hard in its own way, but like they kind of don't have to take in consideration so many elements, right? And for you to like physics, like all these things are just like you have to worry about them.
I think software I'll separate in two categories. The first one is on the logic. Their goal is to detect a bottle, find where is it in space, and find how to get there, right? And then you will get the low-level control, which is how do I get there? So what kind of motors do you have? Where is my current position? Where is the next position I need to reach? So there is the two software part, right? And what they want is that the hardware, the mechanical, is perfect. So that when they ask the robot to move there, it moves there. It doesn't move like, a centimeter away. It moves there. So for them, they just want something perfect. And on the mechanical side, of course, we want to provide that, but, we have a budget constraint. The business team is like, if your robot costs 30 million yen, which is how much? $200,000. I don't know the
30 million yen is like roughly 200.
yeah, let's say $200,000. Like business team is not gonna be happy.
Right,
So business team is like, hey guys, we wanted to make it cheaper, so we make it cheaper. But then like software team is like, yeah, but now we don't reach the position that we want. So can you and you know, if you tell software team, well, that's the way it is, just deal with it, then they will be unhappy and they will think that you are not making any effort to comply with their constraint. So what I found the easiest way to do is just tell them, well, you can go talk to business team, and if you want this technology, I can make it, but here's gonna be the price.
Yeah.
So now you can go talk with business team and check with them if it's fine. And you know, it's your responsibility now. I can make it, but I know that they're not happy with it.
It's probably the best way. Otherwise, you try to please two parties at the same time all the time, and like it's gonna be.
So yeah, for the mechanical engineer, we are trying to make software team life easier.
Yeah.
But there is so much we can do with the budget we have available.
Yeah.
And so software team, their whole job is to manage to reach the goal they want with the crappy hardware that we give them. Yeah. And the electric side, for them, is just we decide, you know, like how heavy is the robot. So they will have to find actuators or motors that satisfy the loads that we have. And they will need to design everything to be able to power those motors. So for them, they're kind of victimized by everyone because they just have to deal with it. You know, it's.
Yeah. It sounds challenging. Like right now, I assume like in your team, you're mostly working with people as passionate as yourself to solve those problems, and I guess that's the fun part as well.
Yeah.
But like, I can't imagine like building the entire thing, and like it must be.
You know, it's like when you work with passionate people, you have passionate discussion, and sometimes it is a bit heated.
Yeah, I can imagine.
You know? It's like everyone wants their life to be easier.
Yeah.
And I think if you want to be a good team leader in robotics, you need to know the other field constraint. You know, software. You need to put yourself in their shoes.
Yeah.
And realize that you have to make their life easier, and if you understand their life, then it's easier for them. It's easier for you to show them why this design is the best. You know, you cannot just come and be like, "Hey guys, that's the way it is," and deal with it.
It's probably important then that like you do have that software knowledge a little bit, right? You do have like even like the mass production understanding now because you understand the cost perspective. Like so you're kind of a complete mechatronics profile now. I can see how a company will be happy to have someone like you kind of because you're kind of in the middle now, also able to manage expectations and stuff. Like I work like I think even when I spoke with you the first time, it was like very hard to know like, okay, mechatronics, mechanical, where do we fit you? Like companies didn't seem to agree with titles. What kind of advice do you give usually to more like junior, you know, mechanical engineers who want to, I guess, market themselves more as mechatronics engineers? Like what kind of advice would you give to younger people?
So I'm a robotics mechanical engineer, and I like to make the difference, because for many years, I didn't know how to market myself. You know, what will be the best title that, you know, kind of represent what I like to do and what I'm good at doing. And so the way I figure out how to find the best title for me is I found companies that will be my dream job, you know. And one company that was my dream job was JPL in the US, which is Jet Propulsion Laboratory.
Okay.
So they are working with NASA. And they are the one who made the Mars rover, and it's so cool what they're doing. You know, it's unfortunately it's very competitive to get there, and if you're not already in the US, it's even more difficult. So I never get the chance to work there, but I found some job offers, and I found job offers that was exactly what I wanted to do, and I just took the job titles that they were using. And from then, I just like to stick to this job title because I know that job title match exactly what I want to do, because there's company that have it.
Yeah.
And that's how I feel.
What about a company that has exactly the same job but does not put the same title on it? Because that's often what we see as well, right?
Yeah. So I will still like to apply because I can read the job description and
Yeah.
figure out whether it match what I want to do or not. It's just, you have to pick a job title that you like.
Yeah.
And the way I picked it is finding a company that I found amazing and just stick with the job title that they use. But to be honest, it doesn't matter what kind of job titles the companies propose, as long as I understand what they want, I can.
Yeah, I think, and especially in robotics, like there's often like those misleading titles, and people get into a job and they're like, "Hey, that's not what I signed up for." Like they end up not doing at all what they were expecting, and
Yeah.
so it often happens actually. But like, I mean, obviously at Lexxpluss now you're working on this new challenge. Like, how is the culture in general? Like, how because I meet a lot of people who want to also to apply for Lexxpluss. I heard like about the interview process even before you. I heard that it was really good. How is the culture? How is work in general?
The culture is great. So, I'm happy with the environment that we have. The engineers are very good. They are very nice. The company is, how to say, is friendly with foreigners.
Right.
It's a Japanese company that understand the challenges that you have of having foreign engineers.
Yeah.
My Japanese is not very good. I have probably about N3 level. I haven't passed the exam, but that's my target this year. And they were fine with that. As a team lead, I kind of start to realize how much I will need to improve my Japanese to really like empower the company. But yeah, the atmosphere is great. Everyone is doing their best to speak English. If you do your best to speak a bit of Japanese, like it's you have to do your part. You're in Japan. So there is no the language barrier is, it's a problem, but it's not a big problem. They manage it pretty well. And yeah, the environment is good. I like it. What I like is that I have time to work properly on engineering project.
Yes.
There's many companies that say we want this to be done in 1 month, and they don't care if you do it properly. They want it to be done in 1 month. In Lexxpluss, they still want you to do it fast. They don't tell you in 1 month. Usually, you tell them how much you need, and then you negotiate
Right.
on
They
how
trust
much.
you basically, and
Exactly.
you're.
And the fact that I can tell them how much time I need. It's not always the timeline we will agree. Sometimes I have to compact it up a bit, but they understand what we will have to skip to reach the timeline. And they are willing to, if what we need to skip is a big deal, then they will be willing to relax the timeline.
Yeah.
And if they consider that those things can be left, like we call it the engineering debt, because you have to work on it at one point, right? But you just do it later. Then they will say, okay, let's pack it up a little bit and let's keep those things, keep it for later. And they are really open to that, and that's what I really like. I have time to do a good job, and that's nice.
I mean, even the way they interviewed you, it seems like they really trust. They know your background, they know what you're capable of, and at some point it's probably like, okay, we hired this guy to do that job. Let's just trust him. And
yeah, exactly. Like I can, they don't blindly trust me. They still expect me to, explain why I take those decisions.
Yeah.
But when I tell them that that's the way we should do it, they understand. They know that I have the background, and they will of course they will ask me questions. They will try to understand.
Yeah, it would be
why,
terrible if they didn't. Right?
Exactly.
Like...
But they don't tell me like no.
Yeah.
This is what we have to do, and please make it happen. They listen to the engineers, and
That's good. Yeah.
Yeah. So.
Awesome. I guess Wilson, like as a last word, to wrap it up, I could probably keep on going on this. Like, I mean, you guys are hiring. Like, what kind of people are you guys mostly interested in? Because we're creating this podcast as well to encourage people to reach out to you for a casual talk. Like, what kind of people are you interested in?
In the mechanical team, we are kind of 100% capacity in terms of workload, which means that we can do all the job that we have to do, but if we get more work, we won't be able to do it. We are like 100% capacity. So it would be nice to have someone else. it doesn't have to be someone senior. It doesn't have to be someone with 20 years of experience. Someone more junior will work too, because...
But from robotics or like?
So at the moment, I think someone who has some knowledge of CAD design, mostly SolidWorks, because that's the software we are using.
Okay.
Some knowledge of, assembling things, prototyping things, that will be the bare minimum.
Yeah.
Of course, if there is someone that knows about FEA, about dimensioning actuators, about more knowledge about the electronic side also, or the software side, a bit a wider spectrum, that will
probably mechatronics.
yeah,
like.
that will be the best, of course.
Mm-hmm.
But having just someone that can do some design and some that will be the bare minimum that we need in terms of mechanical engineering. In terms of hardware is more or less, it's more about the PCB design, the electronics and all that stuff. I think there is also room for that.
So electrical, like...
Yeah, electrical engineers. Electrical engineers that knows about the firmware. The firmware is essentially the software that you put on microcontroller as opposed to microcomputer. I'm not going to explain the difference, but electrical engineers that knows about the firmware will be a very good candidate.
So some knowledge of C development and...
Yes, C. I don't. I think they might be using C++. Yeah, I think they're using C++.
But yeah, low level, like bare metal development.
Low level.
Kind of,
So like, knowing how to code on STM32, which is a very commonly used microcontroller, would be nice. How to flash it, how to read like all the environment of the firmware design, reading the sensors, knowing the communication protocol like I2C, SP, ICANN, all those things, that will be a big advantage. And I think on the software side, someone who knows about like autonomous navigation, like
SLAM, like this
SLAM, path planning, like all those things, like also fleet management, because we have like 15, 20 robots in a confined space, and there is a problem, which is when two robots come in front of each other, they might start oscillating, which is I want to go right and this one want to go right, and then they realize and then go left, and then sometimes it happens to humans too. You come in front of someone, you go right, they go right, and you just that's something that with fleet management we can try to avoid. So there is that on software, and then on the maintenance and field deployment also. There's
like field service engineers.
Yes, exactly.
Probably need Japanese for that.
I think Japanese. Like we have a lot of Japanese speakers, so.
You guys are around 50 people right now.
Yeah, about that. But I think for field engineering, for field support, the Japanese is quite important, because
usually
you have to
kind
talk
of rules
with the customer, right?
Yeah. Awesome. Wilson, thank you so much. It's been so much fun.
It was
learned
fun.
so much, and I'm sure the people in my network that want to learn more will learn a lot from this conversation. Thank you so much.
Thank you.
Thank you.